So just to paint a picture of the use cases in particular. So CS50 for many years used FAS's on-campus Unix or Linux infrastructure. These days it's called nice.fas.harvard.edu. This is a cluster to which students traditionally in years past would SSH or Telnet. They would have a shared home directory, and they would write their code using GCC and other tools at a command line. Over time, that evolved into CS50's own cloud of sorts, whereby we used VMware's ESXi software, essentially to run our own rack servers here on campus to mimic the same idea of nice.fas, but we administered it ourselves. We had root access and generally could do what we want with the infrastructure. These days, we actually use largely client-side virtual machines with students. We don't have them connect to a central infrastructure for interactive work, but we do continue to use, obviously, a web-based infrastructure for distribution of content, as well as a cloud-based service for archival of the course's assets, which these days, as you'll see, are in the hundreds of gigabytes and in the hundreds of terabytes for the distribution thereof. So that's the problem that we thought we'd focus on today. Not interactive student work, but rather distribution of assets. So we have two main infrastructures that we use cloud services for, in particular Amazon's, with which we've gotten quite familiar over the past few years. So in particular, we use the Elastic Compute Cloud. EC2, pictured here, might be one virtual machine, and this can run any number of operating systems. These days, we happen to use Fedora. But we have a replicated structure, so here we might have two or more such servers in CS50's backend, and this is just so that we have a bit of failover and redundancy so that we can also handle the load too, both on campus and off. The types of services that we run on these virtual machines are things like the course's discussion software, the course's video player is hosted here, the course's submission tool, and really any of the web-based applications the course has runs these days on Amazon's EC2 cluster. And we also use backends like MySQL. The applications themselves tend to be written in PHP, but we're increasingly using Node.js, and in theory, we could use most any stack that we might want. Just to put this now into context, we also use Amazon's ELB, which is the Elastic Load Balancing Service, which is actually a very easy way to distribute load across any number of backend servers. And this ELB instance, so to speak, this load balancer, just has a DNS name, a CNAME, that we then map to one of the course's own domain names that we own. CS50.net is one that we use the most. And this is how students, for instance, end up going to the various backend servers that we have. Meanwhile, just to toss out another acronym, and then we'll quickly steer toward a focus on content, we use RDS, the Relational Database Service, which is essentially a MySQL clone that is distributed and run by Amazon itself, to which all of our backend servers connect. We use their virtual private cloud service. Drawn here is just to say that we have a private network, essentially, within the cloud. So we have our own IP address scheme, our own firewalling scheme. So we can essentially replicate in the so-called cloud anything that we might have done here traditionally on campus. Students, meanwhile, might be depicted here. And what they interface with largely is like www.cs50.net, which then hits all of that back-end infrastructure. And just to paint a picture of other services we've used, in large part, not to focus on these today, but really just to set context if you have questions about these or any ancillary services, we use Route 53, which is Amazon's DNS service, whereby we maintain all of our A records, CNAME, MX records via Amazon's own service there as well. And we maintain we use rather SES, their simple email service, which is just an SMTP service essentially, but it's been particularly useful for edX when we want to send out not hundreds, but hundreds of thousands of emails all at once, ideally without getting ourselves blacklisted. They handle a lot of the headaches that we might otherwise run into. And just a couple of lessons learned, just to say that it's not all been rosy and perfectly drawn here. One, we were way over capacity actually years ago. CS50 started participating in edX in 2012, and we had no idea, truthfully, what to expect. MOOCs were sort of all the rage at the time, and still to some extent now. We didn't know if we'd have hundreds or hundreds of thousands of people banging on the course's servers at once, so we probably had about 6 application servers ready to go, 2 databases replicating across each other, a load balancer in front of everything. And long story short, we did have some peaks early on, about 40,000 students in the first day of October 15th, 2012. Really hit the infrastructure hard. But thereafter, it plateaued and reached an equilibrium about 3,000 users in any given time window, banging on the servers at once. So this picture is actually representative. We scaled most everything back so that we run most everything in duplicate, but not triplicate or more. Servers these days have handled quite a bit of load. Another lesson learned, this elastic load balancer, turns out that if you're going from 0 users on day 0 to 40,000 within just a few hours, it's best to tell Amazon in advance. since the elasticity only works when they have a window of history to get a sense that your load is increasing. And if you instead have a step function, essentially no users access your website until Amazon realizes and adapts. So we actually had a slow user experience in the first few hours of launch for edX, because I didn't know I was supposed to pick up the phone and tell Amazon in advance to please turn on the elasticity. Normally, it's not so much a step function, but a line. So just FYI, if you start using load balancing, read the fine print, which I clearly didn't early on, as to how you can actually expect a particular load. And lastly, I'll mention that Route 53 has actually helped with kind of a corner case. We, for instance, have cs50.tv, which is a domain name that the course operates its open courseware at. So that's an A record in DNS speak, if familiar. It's not a C name. And long story short, what's nice about running not only all of your architecture on Amazon, but also your DNS, is that everything is very nicely intertwined. So that if Amazon presumptuously changes an IP address, internally or externally, of any of our services, so long as you're using their DNS and not GoDaddy, for instance, like we previously were, where we buy the domain names, everything automatically adapts. And so that, too, has solved some unanticipated headaches. But the primary focus for today is on this picture here, the distribution of CS50's content, which includes videos and PDFs and images and the like, and the archival thereof. And the services that are most germane to what my colleague Dan was about to talk about is Amazon's S3, their simple storage service, which, as you'll see, is where we store our assets long-term. CloudFront, which is their content delivery network, which sits in front of that layer and handles particularly our increasingly global audience, among which would be one such student here. So let me introduce Dan Coffey.
All right. Hello, everybody. I'm Dan. And just like David said, please feel free to interrupt with questions along the way. But I'll be talking about largely video distribution. We do distribute PDFs and other documents. But since video is so much bigger than everything else, we'll be talking largely about that. All right, so to give you a sense of what our outgoing data looked like for CS50X in 2012, for a bucket size at the end of the semester of 335 gigabytes, that's all of our videos, everything pieced together in our S3 bucket, we output 342 terabytes of that around the globe. For a comparison of a local course, CSE1, which took place in spring of 2013, where we didn't have this large X audience, we had a bucket size of 123 gigabytes of source material, and that ended up being distributed 27 terabytes worth around the globe. So that's just to give you a sense of our scale. So in the old days, people would connect from their location, wherever they were, to your server and get the data. So that's great for somebody who's connecting, who's nearby. So if you're at MIT and you're connecting to Harvard, that's a nice short distance. You're probably going to get a pretty good transfer speed. But what about somebody across the globe? If they're coming all the way from China or somewhere else to get to your server, you're probably going to have long load times, potentially timeouts, that kind of thing. So that's where we get to the CDN, or Content Delivery Network. So what is a CDN? Basically, a CDN is a distributed series of servers, or edge servers as Amazon defines it, around the globe. And so the idea is that your user, wherever they are, connects to a plate that's close to them geographically, so that the number of hops they're making to get to the data is relatively low. So to paint a picture of what CS50's topology looks like, David had this up earlier in the boxes, but basically we start here at the local copy. And so for us, we have a local server on campus that we synchronize all of our data to. This is a Linux instance running with just a fairly large hard drive attached to it. Then we synchronize that data to S3, and I'll get into some of the details of this momentarily. But we can synchronize between the server and S3 so that they're mirrored copies. And then we hook up CloudFront so that CloudFront has its copies. And that's basically where it takes all the data from our S3 buckets, moves it to the edge server so that it's physically close to the users at the end, and then people can download with their high speeds. So let's look at where all this starts. So once you log into the Amazon Web Services interface, this is basically the screen that you get. I've highlighted S3 here to give you a sense of where we're talking about. But let me first set the scene for you. So we shoot lectures in Sanders Theater. And when we're done, we leave with a whole bunch of media, and we ingest it into our editing machines, make a final product, and we have a couple of files. We start with a mezzanine file, which is a large MOV file, very high bit rate, and this is kind of what we'll end up archiving at the end of the day. And we also have a series of WebMs, MP4s, which we will then distribute to our audience around the globe. So S3, or the Simple Storage Service, is essentially just like a hard drive in the cloud. You can connect to it via means of FTP, SFTP, and you can transfer back and forth. One of the benefits is that once you upload an asset to it, you get a unique URL, which you can access or lock down so it's private, so you can distribute that. But the problem is that when you set up one of these buckets, the S3 bucket, as you will, you have to pick a geographic location to where that bucket will live. So typically what you do is you pick somewhere close. So the nearest instance to us is Virginia. And so we set up our bucket in Virginia. So our transfer speeds are pretty quick to synchronize everything to it. But again, we get that user from around the globe coming in. They're not very close to Virginia. And that's where we hook up CloudFront. OK, so there's a few ways to interact with AWS. They have a very nice GUI. And in the few years that we've been using it, it gets better and better every semester, the amount of features that you have. And it's really nice. But they also, if you're a bit more technical, offer a series of command line tools, which they provide. And they're fairly easy to use as well if you're comfortable at the command line. One of these tools, which we use to synchronize, is called S3 Command. And if you're more technical, you may have used rsync before. And it's basically a Python script that runs at the command line. And it takes a lot of the same parameters as rsync. And so going back to our topology picture, we have our local server. And we synchronize that to our S3 bucket. And the mechanism which we use at CS50 is S3 Command. You can run a sync command. If you are a little bit less technical and a little more comfortable with an interface, we highly recommend Transmit. This is a paid application, but it's a fantastic FTP or SFTP client. But one of the really neat benefits of it as well is that you can connect directly to S3 by clicking the tab that's highlighted. So you can log in just like it's any other server that you would remotely connect to. You can drag and drop and download. You can right-click and get a URL for a file. And it's just a really nice GUI interface. All right, so jumping back in our story, we've now edited our lecture. We've transcoded it to our different flavors of MP4 or WebM. And now we need to distribute it. So we've uploaded it to our local server. We've synchronized it to our S3 bucket, which is our source. And now it's time to bring in CloudFront. So there are many different configurations which you can use with CloudFront. You can configure the source. So we use an S3 bucket, but you can also configure it to pull directly from a local server somewhere. You can configure multiple sources. If you have some content you want to serve from S3 and you have some content that you want to serve from a local server, you can do that as well. You can assign CNAMEs, so you can use your custom URLs. Like David mentioned, we have our own custom URL. You're able to define rules for how long the data lives, the time to live, basically. So if a user is, if you've edited this lecture and you realize, oh, I've got a mistake, but you've already published it, you can define the amount of time before Amazon says this is now old data, check and see if there's a new copy. And basically, let me take a step back. So as people connect, they connect to their local edge server. So it's usually done through DNS. And what happens is they'll connect to Amazon. Amazon will say, OK, here's your IP. You're physically closest to this location. You pull your data from here. So they pull their copy from that server. And what the server does is when they get that request from the user is they look back at your origin server and say, hey, which is the newest copy of this lecture video? And if the edge server has the newest copy, it'll just feed that right to the user. And if they don't, it'll go back to your origin server. It will pull one time instead of having all your users hit that origin. And it will hand off that file and then hand it to the user. And this is all seamless to the user. It's just a very smooth process. But sometimes you do your edit and you realize, hey, I need to slow down. I've put the wrong title on and I need to ship a new version. So what you can do is you can set a time to live for your content. So say 24 hours after you've published something, the edge server will always grab a new copy. Or you can manually run an invalidation. And with Amazon, this is really easy. You can log into their interface here in this End tab and say run an invalidation on this path. Or you can use S3 command if you're comfortable. Whenever you publish a new file, you can say invalidate any previous entries. So then as soon as the next user connects, or within some number of minutes, they'll reconnect and pull the latest copy of the file instead of an old copy. And please, again, any questions along the way, please feel free to ask questions. All right, so there's a few things with CloudFront. It's now equipped with analytics, which is nice. Like when we first started using the service, this didn't exist at all. But it's very high level. You get a rough sense of how many HTTP requests are being made. You get a sense of how much data is going, but you don't have any details as to where it's going. So you can get a very high level of how you're performing, but not much beyond that. So if you're looking for more detailed analytics, we turn to a service called CloudStat. And we've been relatively happy with this. It gives you really fine-grained analytics. You can set it up to work with either S3 or CloudFront. And so up top here, we have our S3 bucket. Like I mentioned, we've set that up where CloudFront pulls from. And we also have the CDN itself, which is this bottom here, this bottom row here. And it gives you a nice high-level heat map to see what your busiest days are, what your busiest months are. But with CloudStat, you can get a whole lot more detailed. And how it's working under the hood, yes?
Any reason why you chose CloudStat versus the Google Analytics? Or just
So Google Analytics is you basically embed that into a page. So it doesn't actually give you details on what users are downloading. So if they download a video, you might get a note that somebody went to the page, but you wouldn't know that they actually downloaded the video. So that's why we went with CloudStat. So on the list on the right here, you can actually see all the methods which you can drill down by and get the detailed statistics. And here's a list of how many requests we had per video. And it gives you a very specific list. You can actually glob these and decide, I only want to see videos with this path, so we can say only videos from 2012 or only videos with the word lecture in it. You can really drill down and get some fine-grained analytics. You can search across a series of parameters. You're not limited to just one. Here's another view. They give you many views of your data. So you can see our spike back when we first launched with edX in 2012. And then it kind of gets back down to a more normal level. But again, you get the number of requests. Yes?
I just noticed you guys have different versions of the videos, like 360p, 720p. How many different versions do you have?
So as far as what versions we have to ship our videos in, we transcode to 1080p, 720p, 360p, and 240p. And we do those in both WebM and MP4. But that's totally up to you. Amazon even has a transcode service, which we've started to look into but haven't started to use yet. So it's totally up to you. Maybe you just have one version of the video that you ship. You don't have to transcode all of these. But we have, I think, eight flavors or so, plus MP3. Oh, wow. So you can see the US here and Great Britain. But on my screen, we have the rest of the world. And so basically what this is another heat map where you can actually see physically the number of connections that you have, where it gives you a reference here. And again, this is all JavaScript based. You pull data in real time, and you can configure what you're looking at for a window in real time. You just change a few drop downs. So I'm going to move forward past this. So one thing that we found is that with really big data sets, we have a lot of data. As I mentioned, it was 354 terabytes that we distributed over just CS50 2012. This service can be kind of slow, and it'll time out, and sometimes changing these menus will freeze up on you. So there's a lesson learned if you're looking at using a service like this. But thankfully, they actually offer an API. And so if you're comfortable at the command line, or they even give you examples, you can actually configure exactly what you're looking for. And you can download a CSV, or you can download a .json file, JavaScript object notation. If you want to use this file, you can put it into Google's visualization API and make your own charts and graphs, or just save the data for later. But then you can really drill down many reports. You could get just lectures, or I don't know. The possibilities are endless. I did want to quickly mention that if any of you are doing live streaming, I don't know if you have used Wowza before. Wowza is a pretty awesome server that's pretty easy to configure. If you're a little bit technical, you can set this up. And back when we were starting our live streaming investigation, you couldn't actually use you could use Wowza in EC2, but you could not distribute Wowza through CloudFront. So it would still be like having that local server where everybody's coming to Cambridge to get your bits. Now, I haven't done it, but I know that it's possible. You can use what's called CloudFormation. So another one of Amazon's services is CloudFormation, and it's basically a templating service. And it just defines a stack of hardware that, or virtualized hardware that will hook up Wowza, a Wowza instance in EC2, to CloudFront, and basically gives you just a series of URLs. So you hook up your live streaming encoder. You put in the RTMP address that is given to you from Amazon, and you can then paste in. It'll give you the URLs where people can access the live streams, put that into a player. And it's very easy to use CloudFront now with Wowza, which is pretty cool. All right, so We are talking largely about Amazon today, but it's really not the end-all, be-all of all of the content distribution out there. CS50 has been experimenting over the past couple of years with a few different services. One that we're using is Livestream, and this one is very high level. It's all done through the web. You can drag and drop. You can create events through a web page like this. And we do largely use this for live streaming, but you can also upload non-live content as well. It gives you a nice organizational structure. You can organize by event. So if you have an event with multiple videos, or you want to connect, you have an event that's going all day, but you only want to like ship each session, you can have the same endpoint that you connect to. Start streaming, stop streaming as many events as you have, and it all goes into a nice organized playlist for you. The problem with them, too, though, is that they don't have great analytics. It's the equivalent of hooking up a Google Analytics number into your account. So you get a hit count, basically, and any analytics as far as where people are clicking from, but that's about it. And the other problem, and a lesson learned about Livestream, is that when their service goes down, which is rare, their help goes down as well. So you might like call help and say, hey guys, your service is down, but you get this prompt that says like internal server error. So you're really out of luck when they go down. So when access control isn't such a concern, and even then like unlisted videos and private videos with YouTube is really powerful. They give you a ton out of the box. So as you know, YouTube is free. You can get it almost anywhere in the world. They give you live streaming now. Anybody can enable live streaming if that's something that you're doing. You can easily set up playlists. They have access control so that you can lock down. So they have a notion of 3 different levels of video. They have public, which is anybody can search, anybody can get the URL. They have private, which is completely locked down, and you actually have to manually add users to actually get to the video. And then they have an in-between, which is, what is it? Unlisted, thank you. So unlisted is basically, it's a URL that you get that's got their strange-looking ID, and you can distribute that, but you can't search it when you search across the YouTube interface. And that's how we release a lot of our videos and organize them within playlists. They have an API for uploading, downloading, if you want to write your own scripts to actually do that. And they give you some really awesome analytics that I haven't actually seen anywhere else. So here's a screenshot of what some of those analytics look like. And what you're looking at is the relative audience retention. So as you go over the duration of this video, what YouTube does is actually compare it to other videos of the same length, and will show you how you perform. So the blue line is actually our organic viewers, and this is a nice flat line. It's our first lecture of last year, and you can see we kind of maintain a constant user viewing average. Some of our other videos tank at the end, but that's when we know we got to go back and improve our content. All right, let me move on here. This is another view that they give you, and you can see the United States again. I have the rest of the map on my screen, but it gives you demographics, where people are accessing from. If people have thumbs up or thumbs down your video, you can find out where people are accessing from, how engaged they are. And you can even compare 2 videos. So we can put our week 1 video with our week 2 video and see how do we do week to week, like where's the drop-off. And we've actually been looking at this data to get a sense of how far into lectures or how far into pieces of video are we losing our viewers, and like what is the ideal length. That's the kind of thing that we're learning from this, and we go back and iterate and try to improve. So that's largely what I have as far as the distribution goes. I'm going to switch over to archiving unless there are any questions at the moment. All right. So you're done with your video. You've exported your transcoded versions, and now you're ready to actually save it for however long you want to save it, indefinitely, we'll say. So it's sitting on your hard drive. Our mezzanine files are pretty big. They're about, I don't know, what are we at now? 40 gigs for a typical lecture. So it's pretty big. So let me show you what we defined as our media lifecycle. And your mileage may vary. You may have a different way to approach this. But basically, our source files at the top here are all of our raw media. So what comes out of the camera, what comes out of a device like this that's actually recording the computer screen. We usually shoot with multiple cameras, so we have like hundreds of gigabytes sitting there. We save those for a year, but I'm jumping ahead. Project files are The actual, like, we use Adobe Premiere and CS50, but if you use Final Cut or Avid or something else, you've probably got a file that basically defines your entire project. And then master file is that mezzanine file that you actually export at the end, a really high bitrate file that's probably bigger than what you're actually going to provide to all your users. So that's just to give you a sense of what I'm talking about here. So at day 0, the day we walk out of lecture and we have all of our media, all the media is backed up on a very fast RAID. That's where we'll actually do our editing. And the project file is created. As soon as the project is complete, on some number of hours or days later, we archive the source files to a slow RAID so we can hang on to them. And like I said, we hang on to them for a year. We do the same with the project files. We do the same with the master file. And what we found is that we typically will go back and make changes if we realize a mistake. But after 1 year, we find that most people, or we never actually go back and make a change beyond that. So we found that to be a nice threshold for where we actually toss the media. So at day 365, 1 year, we at that point say, OK, we're not going to make any future edits. We jettison our raw media, which is that isolated camera angles and everything. We get rid of the project file, because what good is a project file without the raw media? And then we archive the master file to Amazon's Glacier. And what's nice about that is then everything is off of our local hard drives. We are ready for a whole other year of production. So I mentioned Amazon Glacier. What this is a really nice tool for saving all of your long-term storage media, or media to store. It's much cheaper than S3. So I don't know the numbers off the top of my head, but they have some really nice calculators on their website. And basically, S3, you pay for the uptime. Like, you can upload, download whenever you want. It's very fast. But if you want to leave lots of data, like I'm talking about these 40, 50, 100 gigabyte files, you're paying per gigabyte for keeping that on. With Glacier, it's so much cheaper, but the trade-off is that it's slower. So once it actually gets into Glacier, there's a 3 to 5 hour window once you restore it, and I'll get into what that means, before you can even download it again. So out of the box, Glacier is a little bit clunky to operate. This is just a screenshot of the Glacier window when you create a new vault. So we started archiving our media through this mechanism, but we did find that it was very clunky to operate. So it forces for every asset that you upload to Glacier, you have to save the ID that they give you back if you want to return it. You can't get it from this interface. You literally have to save it when they give it to you. There's no hierarchy. So we have a very structured hierarchy on our CDN server, and that's so that we can keep track of everything in a nice, organized fashion. That notion is gone when you get to Glacier. You basically upload one file, you get an ID back, and it's up to you to store everything else. It's really very frustrating. And then the kicker is that once you say restore my object, you have 24 hours to download it. So I mentioned sometimes we're archiving 100 gigs, 200 gigs, maybe. I tried to download one of these archives, and it would have taken me 25, 30 hours. It's gone after 24 hours. That's it. So what's the solution, right? The best of both worlds is actually the solution. So we use S3 and Glacier. And what this lets you do is you create your S3 bucket. We have a separate bucket for our archives. You upload your large files however you want to using S3 command, transmit, some other mechanism to S3. You set a rule set for how long that media actually lives in the bucket, and you can set that globally. You can set it per file. And you say, hey, after 0 hours, which is what we do, send this to Glacier. Don't let it sit in S3. We don't want to pay those charges. So what's nice about that is it's totally up to you to create that hierarchy. If you keep a structure that you're organizing, like if you see up here, we have the path for our organization here. You can organize it however you want. And this is window is a cascade here, so you can see layer upon layer. But at the end, what we do is we have like some images, we have a few notes and other files that we archive. So we tar them all up into a tarball, and that's what we end up archiving. So this is just a really big, long file that is many, many gigabytes. What else do I want to say about this? So one of the best parts, once it's actually up there, retrieval is dead simple, and I'll show you that in just a slide. But there's no cryptic command line. There's, again, like with Glacier itself, without S3, it's almost impossible to, well, it's not impossible to get stuff back. It's just a lot more complicated. So let me move on here. OK, so this is what it looks like if you actually look at the assets themselves. I'm all the way in our structure here to our 2012 archives. And you can see that unique URL that you get. It's currently locked because you can set access levels. If you want to make it public and let everybody download it, you can, or you can keep it locked down to just yourself. So once things are archived, they go into the storage class of Glacier. You can see how big our archives actually are. And then within a couple hours, it actually shows up in Glacier, and it's impossible to retrieve if you try to download without restoring it. And then I mentioned restoration. So to get your media back, it's as simple as going into this interface, figuring out what it is that you want to retrieve, and literally clicking initiate restore. And then 3 to 5 hours later, that is available in a bucket, and you're able to download.
So it's tar, is it compressed?
We don't compress. So if you want, you can. It's up to you. Like the tarring is what we do ourselves. So if you wanted to do gzip or something, certainly possible. But we just do a straight tar.
They transfer it as a straight tar as well?
Mm-hmm. Yep, exactly. However, you could upload all your MP4s. You're just going to have a million assets at that point if you have a million files. So we found it easier to segment everything as a single project because we have a much fewer number of those than actual files.
It's just the computational complexity of trying to compress an already compressed video file. So we would get some savings on the PDFs, but they're more than overwhelmed by the video size files.
And that's my last slide. So questions?
Does Amazon provide this interface between Glacier and S3 on
Yes. So the question is, does Amazon provide this interface for you between S3 and Glacier? And yes, they do. It's literally in the S3 interface, and you just say, archive to Glacier after X number of hours or days, and then it automatically happens. And if you want to do it with just one file, you can click on that file and say, archive to Glacier.
So where S3 Glacier appeared in that hierarchical breadcrumb list that you showed, is that something you guys set up, or is that actually like an Amazon service that go forward a slide? I'm sorry, you're going back forward.
This one.
Yeah, you've got all buckets S3 Glacier. Is S3 Glacier a class of the Amazon bucket?
No, I'm sorry. S3 Glacier is our bucket. Okay. So you could call that whatever you want. We called it S3 Glacier to make it clear to us that it's our archive bucket.
Storage classes of Glacier. That's what.
Oh no! So the S3 bucket will never have a storage class of Glacier. It's everything in the bucket that will have the storage class of Glacier. Yes.
So a question about reuse of content. When you give a lecture, do you retake the lecture again every year, or do you reuse lectures that you've given in the past?
We reshoot lectures every year for CS50.
Just because the technology is updating so much that that's the nature of the...
Correct. Invariably, things change. We do have a subset of CS50 curricular content like shorts, which were inspired by edX, which are 10-minute videos, for instance, on very specific topics, and those are reused and have a shelf life we anticipate of 3 to 5 years, but lectures and sections are reshot every year.
So what service level does Glacier give you? In other words, does it make multiple copies, or does it check the integrity of the data, or what are we guaranteeing you when you put in Glacier?
It's been a while since I've read the fine print. It's some number of 9s. It is, I would have to defer to their online documentation as to what the guarantees are. The short answer is, though, yes, it is absolutely redundant, and the price you pay is the speed that Dan alluded to, but the price point is like an order of magnitude less than S3.
One more. I don't know how much you can go into the cost of Glacier. Are there different levels of service that you get with Glacier? You said something about the speed, where it's just...
No, Glacier. Once it's in Glacier, the more data you transfer and store in Glacier, the cheaper your costs get, just like with most of the other Amazon services, but it's a flat pricing after that. And
it's been a good year since we ran the numbers, but before Glacier existed, the numbers were such that if we tried archiving the same content on S3 only, it would have broken the bank, and it was cheaper than just use on-campus servers at the time.
Yeah, I'm over in the law school, and we're starting our own uploading of library content to S3. So in ABCD fashion, is there a mechanism where we can leverage Harvard's buying power for these kinds of services and maybe share that? Have you guys been involved in those discussions?
We have, and we largely do our own thing in collaboration with edX for this class in particular. I believe Jim Waldo, CTO, is probably the best person because I believe he's been involved in those chats. That would be my recommendation. Him or Anne have probably been involved in those chats. edX has done its own negotiations, and that's what we piggyback off of. And they are very good, too. If you Google Amazon Web Services grants, they actually tend to be very generous, particularly if your use case is largely academic and less IT, for instance, of giving a few $100, a few $1,000 in credits so that you can at least experiment with the services.
How long have you found it takes to upload a 50 gig
50 gig file. So I typically let this run overnight when I have a script that basically walks our whole directory, looks for anything that's the right age, tars it up, and then uploads it. But I would say, again, just your mileage may vary. Probably 50 gigs, a couple of hours.
Okay, so it's done by the morning.
Yes.
What's the security around those files that you send out? How do you maintain the integrity and all the else on top of it?
For the most part, for S3, we have made the conscious choice of making almost everything public. A few exceptions include some of the solution sets that the course has to homework assignments, as well as to the backups that Dan alluded to. You can do pretty fine-grained permissions. We, for instance, for the Glacier backups, just say they're entirely private and there's no individual accounts that can access them other than ours. However, you can use one of Amazon's services to create individual user accounts that have access to whole buckets or even to individual files. If the question is motivated by a desire for access control outward facing, like via the web browser, we tend not to take advantage of this, but with S3 you can also create digitally signed URLs so that you can make everything private by default, even though we don't do this as a matter of practice, and then using a bit of Python, PHP, or any language code using Amazon's SDK, you can generate an ephemeral URL that's good for a minute or 5 minutes or a day, so that like an extension school student, for instance, could download that video, but not someone randomly on the internet.
And actually, I don't know if you want to mention the torrenting benefit as well.
Actually, that's true. But what you also get with Amazon S3, if this is of interest, is for torrenting out of the box. You literally just append !torrent to any Amazon S3 URL, and Amazon takes care of the tracking and seeding of that file, which has been great for our international audience who can download only a few kilobits per second sometimes.
So I don't know about the nature of archiving the lectures over the past lectures, but let's say if I'm taking a course of yours, let's say 2 years ago, and I want to go back to what you taught, can you do that? Can students do that?
CS50.tv has every asset since 2007.
Oh, so aside from the archiving, you still have all the information?
Correct. For the medium-sized files like the MP4s and the WebM files that we've outputted for years, all of those have lived in perpetuity on S3. It's the bigger files, the master files, that get archived to Glacier and are inaccessible. All right, well, please feel free. If the video, the slides, or even an introduction to some of our friends at Amazon are of interest, please just drop either of us a note. Thank you so much.